And it's my pleasure to invite our guest lecturer, Professor Daniel Chamovitz, known to his many friends as Danny. Danny did his PhD quickly. I know. You want to talk. I'll leave you a few minutes to talk. I promise. He was trained as a plant molecular biology. He did a postdoc at Yale. He then was recruited to Tel Aviv University, where he did a lot of impressive and innovative work, mostly in plant evolution, development, but also going beyond plants. He went through the ranks and eventually became the Dean of the Faculty of Life Sciences of Tel Aviv University. And about 2.5 years ago, he was nominated as the president of Ben-Gurion University. Danny is best known for his work on the COP9 signalosome, which I'm sure all of you know about. I think if anybody here doesn't know what the COP9 signalosome is, raise your hand. No hands. Good. And I'm sure that Danny will be happy to tell you much more about the COP9 signalosome if you want to know. But now Danny is going to tell us about why we care about what plants know. So Danny wrote a successful bestseller called What Plants Know, translated into many languages. And if you want to know what plants know, here we have Danny to tell you. Danny, please.
The parents, you should be incredibly proud of your children. What they have accomplished with this scholarship basically shows that they have what it takes. It's their passport for what I have in my pocket. And what I have in my pocket is an offer for a job at Ben-Gurion University in 7 years. And I will gladly sign any of you right now as a futures for Ben-Gurion University because you've already proved that you have what it takes to be successful scientists. The rest is just doing what you need to get the 3 letters after your name and to get a few first paper articles. But I know that you'll be successful, so if you're ready to sign now on a 7-year futures contract, come up to me afterwards. Second of all, it's incredibly humbling to be here with these people in the front row for me. If you guys ever want just for fun to do a Google Scholar on Moshe Oren and can guess how many citations he has, or on Ruth Arnon, and you'll see the difference between really good and excellence. And what we talk about with the Adams Scholarships is really excellence, and that's where you should be aiming for. So it's a real honor for me to be here. And one other thing, I'm not here because of protectia. Nili was rector of Tel Aviv University 6 months after I was hired, and she left 6 months before I got tenure. So I'm here. And I also want to thank Sylvan for giving me the opportunity to speak in a difficult language in English. So thank you, Sylvan. So now, let's get why do we care about what plants know? And can we even talk about this word? What does a plant know? Well, let's talk about for a second about what we know. How do we, one second. How do we understand our world? How do we sense our world? You think about it, if you go to the beach in Tel Aviv, if we go to the beach in Tel Aviv and you see this going down, you see the sun setting. Can we say, though, that plants see the sun? We know how we sense our world. Or, we smell flowers. But do flowers smell? Of course they smell good. But do they smell? Can I even use these words? If you're listening to the orchestra, most of us, I hope, love to hear classical music. Love to hear good music. We love to hear children. It's really okay, don't worry. Because these are the sounds that make up our life. But does this mean anything for a plant? Or what about, we taste plants. But do plants have taste? And what about a sense that we don't even take, or we feel, if you're barefoot, you feel plants all the time in the grass in a park. But does the grass know that, or do they feel us walking on them? Or what about this ballerina? I tried to do this. Look how she is perfectly aligned in space and time, knowing where every muscle is, where every bone is. This is a sixth sense that we have, and the sixth sense is not ESP. The sixth sense is proprioception. We only notice it when we're drunk because we've lost it. But how does we know where we are in space, and how does a plant know where it is in space? So if we look at this forest, what is it experiencing? Can we even use the word experience? So let's start with a simple question about what do plants see? And now, at least for the students from Tel Aviv University who I hope took my class, you should know that even before we get to that. So what do we see? We see pictures. This is the view from my office at Ben-Gurion University. And if I was blind, this is what I would see. Nothing. So we intuitively know that there's a clear difference between seeing and being blind. But now let's do a thought experiment. If we would take someone who's blind and now through some surgical intervention, allow them to differentiate between black and white and gray, are they still blind? Or are they seeing? You're allowed to respond. They're seeing something. It's better. And if you would allow them to differentiate between red and blue, that would be an improvement also. Their experience would be a little bit different than being blind. So if you can accept that seeing is not only seeing pictures, then plants see at least as good as this. And the truth is, you all know this. Because if you look what happens to your plants on the windowsill, they grow towards the light. Right? If you move them, they'll start bending in the other way towards the light. So somehow or another, plants know where the light is. And as at least I hope the students from Tel Aviv University know, the first person to study this was Charles Darwin. In his last book, The Power of Movement in Plants, Darwin asked the question, how do plants sense light? And he wrote, this is actually a picture up top from his book from 1888, I believe it is. This is the 1880. He said the plant was so sensitive that it would bend to the light of a candle that was so dim that I couldn't read my watch from. So plants are incredibly sensitive to light signals. But not only are they sensitive to light signals, but they differentiate between colors. Because if you put blue on one side and red on the other, the plant will always grow to the blue light. And we've known that also for over 100 years. But every time I show this, usually people go, wow. So can I hear a wow? Thank you very much. Okay. So what do plants see? Actually, plants see a lot more than we do. From a plant's point of view, we are visually challenged. We can see wavelengths between about 400 nanometers to about 650 nanometers. That's what our eyes are tuned to see. We have 4 photoreceptors in our eyes that see these different wavelengths. But plants have upwards of 13 different light receptors, photoreceptors, that differentiate between wavelengths down to 200 nanometers up to 750 nanometers, things we are blind to. So from a plant's point of view, we are visually challenged. And why does a plant have to be so sensitive to light? Because it has to know where light is in order for it to get to photosynthesis, because light is its energy for growth. So of course it has to know where it is so it can get to it and change its entire development in order to be completely attuned to the light environment. All right, so if that's not too surprising, what do plants smell? I'm going to show you a video of 2 plants, a tomato plant and a plant called cuscuta, daughter, hops, which is a parasitic plant. Now take a look here. That's the parasitic plant. And there's the tomato. And look how this thing is moving. Let's go look at this again. Was this random or was there a directionality? In the beginning, it looks one big circle, but the circle keeps going a little bit more to the left and more to the left and more to the left until it eventually finds the tomato, wraps around it, and starts sucking the sugars out of the plant. So the question is, how does the kuskuta, the hops, know where the tomato plant is? And I want to describe one experiment that was published in Science about 15 years ago. There's no molecular biology involved. You don't have to use molecular biology to be published in Science. You just have to do a really good experiment. And here was the hypothesis is that the kuskuta is responding to a volatile signal. I mean, what is smelling? It's a volatile signal that comes through our noses. And so here's the experiment. It's a rather simple experiment. We have 3 boxes that are connected by air pipes. Here in the middle, you have a pot with seeds of the kuskuta. On the one side, tomato, and on the other side, a control, an empty pot. And when you let the seeds germinate, they grow in the direction of the tomato, or the air of the tomato. Okay, so now they did the next experiment where they took an empty pot and they made an extract that they could spritz in the air of the tomato leaves. And still, it grew in that direction, which sort of is the hypothesis, fits the hypothesis that it's a volatile signal. But now comes what I think is the most fascinating question. Does kuskuta like tomato, or does it like plant? So what's the experiment to do? Switch plants, right? Let's switch plants. Now, have any of you ever drunk, this is actually the true experiment, wheat seedling juice meets nevet chita? What does it taste like? Awful, nachon? You drink it and you want to say moo? You have to hold your nose to drink it. Now, this, my wife was making me drink every morning meets chita, wheat juice, because they say that it reduces cholesterol. And maybe it does, but it tastes not. So this is the true result. The kuskuta would rather go to the empty pot. Not only did it not go, it went the other way. And when I read this result, I stopped drinking it because I said, this plant is smart enough not to go to it. Then who am I to drink it? And of course, if you give the plant the choice between the smell of the tomato and the smell of the wheat, it will go to the wheat, the tomato. So plants, so what do plants smell? Not quite as much as they see, but they do smell things in the air, chemicals in the air, which lead me to a question about what do plants talk about? And the reason I can ask this question is because, again, of an experiment that was done, also published in Science. This was done in 1981. But what they showed after many years of research is that if one willow tree is attacked by beetles, it gives off a gas called methyl jasmonate, a volatile gas, which is then picked up by the leaves of the neighboring plant, where it signals the formation of chemicals that are poisonous to the beetles, and so then the tree becomes resistant. Now, when this was first published, before they knew the mechanism, there's a lot of anthropomorphism you can do with this. You could say, oh, save yourself. Oh, the beetles are coming. You know, they're trying to help each other. Now, there's lots of models, as the students know in evolution, that show that there is an advantage to be altruistic. But here we get into a problem of interpretation. Because one interpretation is that tree A is signaling to tree B. And that one fits in our altruistic desires for altruism. But there also is another possibility. And the other possibility is that they're just eavesdropping. Meaning that when this gas is released from this branch, it also influences another branch on that same tree when that other branch becomes resistant. So it could be that it's just inter-tree communication and the neighboring tree is benefiting from it. And we can't know because we don't have tree psychologists. We can't ask the tree, what do you mean? But at least we know that the communication exists. So if we look at what plants smell, well, plants communicate by volatile signals, much in the same way that animals do. We have a lot of communication that we are not aware of that goes through the sense of smell. Call them pheromones. It's smell. You know, and even in literature, we talk about the smell of fear was in the air. So we also communicate through our senses of smell. And what do we communicate? Our physiological situation, just like plants are communicating their own physiological situations. Okay. So if plants see and plants smell, what do they feel? You know what's going to happen, right? Now, why does that bother you more than the fly? They're both prey, you know, and they're both needed by the plant in order to. So how does the Venus flytrap know? And notice, it's not only that it knows that it's being touched, it waits. It's waiting until it's in the middle, and only then does it close. So obviously, the Venus flytrap feels its prey. And we now know that it's an electrical signaling of two different hairs have to be touched within 30 seconds. You get an electric potential that goes through the leaf, much like a muscle. It's not a muscle, it's not a neuron, but it's the same physiological process of a depolarization, which causes the leaves to close. So they are sensitive to touch, to pressure, which opens an ion channel, which leads to a signaling event, the same way it works in us. Different cells, different tissues, same outcome. Which shows that another thing we know is that plants don't like being shaken. You know, we don't want to shake our kids. Of course not. But this is Arabidopsis plants that are 6 weeks old. The only difference between the pot on the right and on the left is that this one was touched by the scientist with a hand 3 times a day since it started growing. And we could see that the being touched stunted its growth. Now, why should Arabidopsis care that Danny Chamovitz touched it? What's it thinking? Is it really being stunted? Now, I'm going to tell you, actually, no, the plant isn't being stunted. This plant is incredibly smart. Because when does this happen in nature? Take a look at a tree in a valley. It's tall, majestic, with a large, I want to say nof. How do you say nof in English? What? No. Canopy. With a large thank you. With a large canopy. And the same tree on the top of a mountain will be short, fat, with very few branches and very few leaves. Intuitively, you're thinking to yourself, okay, the wind damaged the tree. The wind didn't damage the tree. The tree survived. What's the biggest difference between plants and animals? The ability of movement. Animals can run away. When we're in a situation, in an environment that's not conducive, we run away. That's easy to run away. You go north or you go south, you go looking for water, you go find shelter, you go looking for a mate, you go looking for food. We run away. But think about this poor tree. It's literally rooted in one place. It can't run away. And because of that, plants have to be incredibly sensitive to its environment and then change development in order to survive. If this tree did not have the ability to say, okay, I'm going to stop growing up, I'm going to make myself fatter, and I'm not going to make myself so many branches, it would die. These are developmental decisions that plants make in response to their environment. Imagine if we would become shorter in the wind. If we had that plasticity. But this tree can survive in minus 20 degrees, plus 45 degrees, drought, in wind, because it can sense its environment, change its genetic expression, change its physiology, and adapt in order to survive. That's much more complex than an animal's response to the environment in many, many ways. By the way, this is the reason that from a genetic point of view, plants have more genes than animals as a rule. Now, when the human genome was done and when the genome projects were, and people found out how many genes plants had, it rubbed some people the wrong way. How could wheat have more genes than people? We're better, right? So more genes must mean that we're better. But plants have more genes because they need all of those genes in order to survive so many different types of environments. It's an incredible genetic complexity. All right, so what do plants feel? Well, like us, they feel pressure. They feel wind. They feel changes in temperature. One last question I want to ask before, what do plants hear? So what type of music do you think plants prefer? Classical music. Anyone else? Low frequencies of music. Well, you know, the thing is, why did I actually write this book 10 years ago? And it was because of my class, Introduction to Plant Biology at Tel Aviv University, where I would teach students, first-year freshman students, that plants could differentiate between red and blue, something we've known for over 100 years, and they would go, wow. And then I would say that plants have no taste whatsoever for music, and they would say, but I read a book once called The Secret Life of Plants. So why do so many people are convinced that plants hear? Is because of this little book here called The Sound of Music and Plants, which was published in 1966, 1967, self-published, by this woman here, Dorothy Redelack. Dorothy Redelack was from Denver, Colorado, or Boulder, I can't remember which of the two. She went back to university at age 50 after her children grew up. She was a devout Christian, born-again Christian. She went to study musicology. She was in her church choir. These are all facts. I'm not making this up. And she was also very conservative and believed that rock and roll was the downfall of American society. And I know as a kid, my parents, who were not conservative, also believed that. I don't know what your parents felt, Sylvan. It's about the long hair, but they go together, exactly. The loud music. So she, as in her music program, she had a science requirement. And so for her science requirement in a music school, she decided that she would prove that rock and roll was dangerous. Now, what's wrong with that type of experiment? You don't do an experiment to prove something, right? Okay, just remember that. If you guys don't remember that, you do want your publications, but it's not in order to prove something. You're testing a hypothesis, but you want to prove that it was dangerous. So she said plants don't have feelings. Well, let's see how they respond to rock and roll. And this is her experiment from her book, For Plants. This is Mozart. This is Ravi Shankar. This is Led Zeppelin, and I can't remember who this is. Because she wants to say that it's not only Western classical music, it could also be Eastern classical music. And as you can see, the classical music plants are doing really well, whereas Led Zeppelin and Jimi Hendrix are dying. Her experiment consisted of 4 plants where she checked the water content with her finger in the plant. She had trouble publishing this. And so that's why she wrote the book. Unfortunately, this book never got sold, except to one person, the author of The Secret Life of Plants. And he quoted this as a joke, so to speak, and it got picked up around the world. How many people here have read The Secret Life of Plants, or at least bought it or have held it? No one? Oh, I'm surprised. Okay, maybe it's really... You never saw The Secret Life of Plants? Okay. The wrong subject. Anyway, no, it's a bestseller. It's still being sold. The truth of the matter is that after years of research, there has been no evidence whatsoever that plants have a musical taste. And for those of you who study evolution, I mean, why would these plants be small, by the way? What did we just learn 5 minutes ago? Plants don't like when you shake them. So if she put them next to the speaker and you're getting a strong bass line going out, stunted growth. The 5 or 6 publications that did make it into Medline, the plants all prefer the music that the scientist prefers. Do I think that they were faking the results? No, I just think we're better gardeners when we're listening to music that we prefer. And it was actually, so what do plants hear? Until 2 years ago, I would have said nothing. But 2 years ago, a group at Tel Aviv University led by Lila Hadani proved for the first time anywhere in the world that plants, one plant, the evening primrose, can hear the sound of a pollinating insect. And when they hear the sound of that insect, they make more nectar. And the reason they did that experiment was because of my book. Because in the hallway, I was talking about it. I said, plants don't hear. And she said, you can't make that statement. I said, why not? She said, maybe we haven't done the right experiment. So then we spent 3 years trying to figure out what would be the right experiment. So remember, lack of proof is not proof that something doesn't exist. It's a really important message for the scientists here. So plant senses, what do we know? Yeah, so I hope I've convinced you. Well, we don't have time to go into plant balance. Plants actually have a memory also. That's actually one of the craziest things to talk about, but plants remember weather, they remember sex, they remember their grandparents. There's a lot of things that plants remember. So if plants remember all those things, why do we care? All right, it's nice. It's entertaining. If you're a plant biologist, it gets you tenure. Well, the reason is because we've got to look at our world today. Less than half the population of the world is food secure. A third of the world is undernourished. Another 10% goes hungry, classic hunger. And another over 10% of the world is overweight, getting too many calories. This is an unfortunate situation which is only getting worse. And so why is it this way? What are our challenges to feeding the world? Let's just go through this very quickly. Well, the first of the one is that population is growing exponentially, and you all know that. When I was born, there were only 3 billion people in the world. When my parents were born, 2 billion. My grandparents, a little bit more than 1 billion. And we're going to reach 9 billion probably by 2050. 3 times in my lifetime. It's just crazy. But at the same time that we're getting more and more population, we're losing arable land. Arable land is decreasing by 100 square kilometers a year. This is where I live in Hod HaSharon. These used to be orange fields and strawberry fields, and now they're apartment fields. We see it all over Israel. So, we have a perfect, a really negative storm here of increasing population. You need more food. You need more food. You need more land to grow it, but we have less land because we have more people. We're going to have to maintain yields by 36% over the next decade in order to maintain the amount of calories that we have just now in the world, and even that's not enough. You add to that the fact that, we're, on the one hand, we've been able to reach this by the fact that every year yields have gone up. Every year over the past 50 years, the yields have gone up. The amount of protein, the amount of seeds per acre. But this is starting to level off. It sort of seems we might have reached some type of biological limit to our yields in many plants. It's distressing. And the last problem that we have is, I used to be one of the few people talking about this. Now I feel like I'm jumping on the bandwagon. Climate change. I don't even have to mention anything about this. And we got coming up the road to Jerusalem, you could see it. A change in temperature of 2 degrees during pollination of wheat is the difference between famine or a full harvest. If the temperature goes up 2 degrees during the week of pollination, the wheat won't be pollinated. What would that effect be on the world? It's really, really scary. But what we're talking about actually is not new. We think we're inventing the wheel. We really want to believe that we're being original. But go back 4,000 years. Why did Abraham go down to Egypt? There was a famine in the land. Famines cause population transfers. 4,000 years ago, and this is over the past decade, people walking from Syria to Europe. Why are they walking to Europe? Not because they want democracy. I know that Americans like to think everything's about democracy. It's not. And I'm American, so I could say that. It's about food. When people don't have food for their children, they don't have water for their children, they leave. If they have food, they very rarely rise up, no matter what the government is. And even think about our own country. Food security leads to social and political insecurity. And who can find themselves in this demonstration from 10 years ago in Tel Aviv? What is the only thing that got 1 million people in Israel to go out into the streets? A rise in the price of cottage cheese. Not the Palestinians, not peace, not the price of housing, cottage cheese. Because when we're feeling food insecure, that's when we become activists. And so a food insecure world is also a politically insecure world. But I'm an optimist. And why am I an optimist? And the answer is probably going to surprise you. I'm an optimist because of India. Now, I'm sure many of you have traveled in India, and why would India make anyone an optimist? But when Sylvan and I were kids, there was a huge famine in India that millions of people were dying, and tens of millions were on the brink of starvation, especially in the state of Bihar. And the only way India survived these famines in the 1960s was through massive, massive foreign aid. You remember that? Yeah. And at that time, there were only 700 million people in India. If someone would have told a policymaker in 1968 that India in 2020 with 1.3 billion people would be a net food exporter, they would have laughed in their faces. There is hunger in India, but it's economic hunger. It's not agronomic hunger. India now produces more food than it needs and exports food to the world. And the way they've managed to do that is by adopting modern practices of agriculture, scientifically proven practices with new seeds, new technologies, which have increased yields and brought wealth to farmers. So what have we learned from this? First of all, there are no simple solutions. 2, partnerships are essential. It's not only plant biologists working in a vacuum. We need people who are working in fields in the developing countries. We need people who are economists who understand what's going on. We need people working in policy. We need students from different disciplines, from big data, from genetics, from engineering, to work together. But at the basis of this, we have to know as plant biologists how a plant senses its environment and responds to its environment so that we can develop crops that are better equipped to deal with drought, crops that are better equipped to dealing with a warm environment, crops that can flower quicker, crops that need less imports so that we can save our environments, crops that need less phosphates. And all of these answers are going to come from science, from research. So it behooves us now to know what a plant knows. It behooves us now, let's try that again. It behooves us now to know what a plant knows so that we can save ourselves in the future. And the reason we're doing this is just that this is my favorite quote from the former head of the FAO. We need to remember, hunger isn't an issue of charity. It's an issue of justice. No one should have to go to bed worrying about where their kid is going to get their next meal. And just I want to take you guys back again 1 year and 4 months ago when COVID started, when we weren't sure when there was the run on the supermarkets, that we were petrified there wasn't going to be enough water, that there wasn't going to be enough food. And we all have enough resources financially to feed ourselves. How did we feel for those 2 weeks? Thanks very much. Also, I need to thank everyone for letting me go back to being a scientist and not a president for an hour. That was more fun than I've had in a long time.
Do you want to take any planted questions from the audience?
I'm sure. I'm always ready to take. I mean, I don't want to keep us. Only planted questions. Sure. If anyone has a question,
Any questions for them?
Ken.
What do you think about the new system of making plants in parkings, subterranean parkings, and all kind of this? I heard that now they are looking because there is not enough land. They start doing crops in subterranean parkings. And what do you think for the plant
So we have to
and
be.
for us after?
We need an entire toolbox of approaches. One of the approaches, for example, you've seen maybe as you've heard a lot about is vertical agriculture. Growing things in cities and this is great for horticulture. It's taking advantage of land that doesn't exist, growing plants. I don't want to plug my university right now, but I'll plug it. Just 2 weeks ago, we got a donation to found an institute that's going to be studying vertical agriculture in the desert because we have to increase that. But our biggest challenge is going to be finding ways of making proteins. And that's wheat, corn, rice, soybeans, because you can never do that underground and you can never do that vertically. That just needs massive amounts of land. But one of the answers, though, is that global warming is an incredible opportunity for Canada and Russia. And I mean that seriously. Sure. No, I'm צריכים את זה בשביל כן.
Hi. First of all, thank you very much for the lecture. It was really nice. I'm interested, do you try to look at how plants would know, feel, or sense things in other planets? Not just on the Earth?
Well, there are experiments going on in the space station on plants. And one of the big questions is, I didn't go into this, is how does a plant know up from down? It's where the light is, right? But on the other hand, if you put a plant in the dark, it still grows up. And when you put a plant in the space station, it grows all over the place. It has no idea where it is. But then if you put it in a centrifuge, all of a sudden it grows with the centrifugal force as if it's gravitational force.
That's exactly what I was about to ask. Does gravity affect them? And then if you can change gravity, then you can maybe change growth of plants.
Yeah, and if there's modelists among us, people who really like modeling, physicists and model, think about if a plant has a modeling problem. On the one hand, you have the vector of light for the plant wants to get to the light. On the other hand, you have the vector of growth, which is you're going to be anti-gravitropic for this, and then you have the wind, which is going to be pushing. So how does a plant integrate these different forces in order to determine its shape? It's actually a physical problem that people are working on.
I got a friend who's doing that, so yeah, that was interesting.
Yeah. Great. I think maybe we can hear what they have to. I want to hear their signs. Great. Thanks very much.